Assalamualaikum. Hello everyone. Today we will solve this Feb March 2023 paper and varies 22. Okay, so let's start. So here I have this page number 1 and let me zoom this page. Okay, so the first question is the Pauling electronegativity values of element can be used to predict the chemical properties of compound. Yes, true. So here we have certain elements: hydrogen, lithium, carbon, oxygen, and sulfur. So first question is define electronegativity. Electronegativity is actually the power of an atom. It is power of an atom to attract, power of an atom to attract shared electron pair, shared electron pair towards itself. Okay, even you can use the term tendency of an atom. Okay, instead of power you can write the term tendency of an atom. Okay, for example, if there's a bond between hydrogen and chlorine, so you can see it is a shared pair between these two atoms. Okay, so now you know chlorine is more electronegative. It means this electron pair is more attracted towards this chlorine. So it is the power of chlorine to attract this shared pair electron towards itself. Okay, it is electronegativity. Okay, so the next question we have oxygen and sulfur on group 6. Yes, if you check group 6, oxygen, sulfur, selenium. Okay, so explain the difference in the Pauling electronegativity values of oxygen and sulfur. So as you people know, when we move down the group, so size of an atom increase. How size of an element increase? You can see oxygen like it is smaller size, then sulfur more bigger size, then selenium is more bigger size. Okay, so you people know down the group extra shell increase. Okay, so when extra shell increases, it means their electronegativity decreasing. Okay, so what could be the reason? When extra shell increase, shielding effect also increase. Okay, so it is shielding effect increase down the group. Okay, understand? So what other could be the reason? Like nuclear charge and shielding effect. So how nuclear charge and shielding effect you can say, like nuclear charge and shielding effect cancels each other. So oxygen's atomic number is 8. Sulfur's atomic number is, it is 16. Okay, it means it has more nuclear charge. Is it clear? Like number of protons are greater, but the thing is size is bigger. Okay, the thing is size is bigger. So when extra shell is added, this greater shielding effect. Okay, so nuclear charge and shielding effect, they will cancel each other. Okay, they will cancel out. Okay, cancel out. Okay, cancel each other. And what could be the final answer? So the atomic radius of sulfur is already told you is bigger. Is it clear? So that is why sulfur has greater nuclear charge. Okay, so now you can see like electronegativity decrease. Okay, electronegativity decrease. Sulfur has lower electronegativity. Okay, sulfur has lower electronegativity. Okay, than oxygen. Lithium hydride, you can see it. Like now we have this lithium hydride. When hydrogen connected with some metal, for example, you have sodium connected with some hydrogen. Okay, so when a hydrogen connected with some metal, you can say it carry negative charge, and sodium will carry a positive charge. Okay, so it is a hydride when hydrogen bearing a negative charge. Okay, so here you can see it is a bond between metal and non-metal. So you can see it's an ionic bond. Okay, draw a dotted cross diagram for lithium. So atomic number for lithium is 3. Atomic number for hydrogen is 1. Okay, if you draw the structure of lithium, you can notice there are 2 electrons. Okay, there are 2 electrons in the first shell of lithium, and there's only 1 electron in the valence shell of lithium, because lithium is also from group 1 member. Okay, so now if you notice, like hydrogen is from group 1, so there's only 1 electron in the valence shell of the hydrogen. Okay, so in ionic bond, one of the atom, especially metal, will lose its electron, and other element like non-metal will attract that electron. Okay, so now it will become, when it is losing its external electron, so the external, no need to write its external valence shell. Okay, I'm writing their second shell. There 2 electrons are present, you can see it here. So lithium is losing, it's a lithium, and it is a structure for hydrogen. So you can see lithium is losing one of the electron, it will bear positive 1 charge. Understand? So what about this hydrogen? So now you can say a hydrogen is gaining that electron from the lithium. So it is bearing now negative charge. Okay. The next question is, suggest the shape of molecule of H2S. Okay. If you see, like sulfur is from group 6, so it has 6 electron in the valence shell. Okay. 1, 2, you can even write this if I wrote it. Okay, 1 electron pair and second electron pair. Okay, 4 electrons are here, fifth and sixth. Now they're being shared with this hydrogen, because sulfur is a non-metal, hydrogen is a non-metal, so there's a covalent bond. Okay, so according to Vesper, this lone pair of electron and this lone pair of electron, they repel actually this bond pair of electron. Okay, there's a great repulsion. Okay, so then you will get this type of bond. Okay, a V-shaped bond. Okay, a bent form. Okay, so what is the shape of the molecule? So you can notice these lone pair of electron, they are actually repelling greatly. Okay, to this bond pair. So you will get a V shape. Okay, even you can send V shape or bent shape. Okay, it's a bent shape, bent, or even you can say they have V-shaped molecules. Okay. So the next question is here. So the question is, write an equation that represents the ionization energy of hydrogen. What is definition of ionization energy? It is an like minimum amount of energy required to remove electrons from independent gaseous atom. I'm not writing a molecule. Okay, it is a molecule. No need to write molecule. Okay, when a hydrogen atom, independent atom in gaseous state will lose an electron, it will become hydrogen positive ion. Okay, so it is the mechanism how to, it is the like process how to write there. So other thing is you will get this in gaseous state. Okay, why there is no information given table 1.1 for the second ionization energy of H? As you know, like hydrogen is from group 1, you can see it here in the table. If you see it here, you can notice there's no any value for this second ionization energy for the hydrogen. Hydrogen has only 1 electron in the valence shell. Okay, it has only 1 electron, there's no other electron in there. So now you can say there's no second electron in the valence shell of hydrogen. Okay, so even you can write it like hydrogen contain 1 electron. Okay, hydrogen, it has yet carry 1 electron only. Okay, understand? Give the full electronic configuration of sulfur 2 positive. As you know, atomic number of sulfur is 16 from periodic table. There are 16 electrons, so it will become 1s2, 2s2, 2p6, 3s2, okay, and 3p2. Understand? So now you can see it is 2 positive. 2 positive, there are 2 electrons deficient. Okay, 2 electrons are deficient. So it is 2 positive. But if I write for this as 16, you can say 6 plus 2, 8 plus 2, 10, 10 plus 2, 12, 12 plus 2, 14. Why they are 14? Because there is 2 positive charge. But if I write like for 16, so it will become 3p4. It will become 3p4. Okay. But the reason is, you can see there is 2 positive charge. So 2 positive charge mean it's already lost as 2 electrons. So it will become 3p2. Is it clear now? So the next question we can say, CO2 and SO2 are acidic gases. Of course, they both are non-metallic oxides. Carbon is a non-metal, sulfur is a non-metal. Non-metallic oxides are acidic in nature. Okay. So write an ionic equation for the reaction of SO2 with H2O. You know, in air, when this SO2 react with sulfuric acid, when this SO2 gas in the air, you know, when it reacts with water molecule, we will get sulfurous acid. Okay, it's not a sulfuric acid, we are getting sulfurous acid. Okay, so write an equation for the reaction of SO2 with NaOH. Already told you they both are acidic gases and it's a base, so the reaction will become SO2 acidic plus base. You know, when an acid react with base, salt and water will produce. Understand? So what you will get? You will get sodium 2 times with SO3. Okay. As you know, when acid react with base, you will get water, salt and water. Okay. Construct an equation for the reaction of CO2 with magnesium hydroxide. You know, it's also an acidic gas, so you will get carbon dioxide react with magnesium hydroxide. Okay, and you will get this magnesium carbonate plus you will get water. Okay, I hope if you are good because you are student of A level, you should be able to understand these hydroxide -1 charge, carbonate carry -2 charge for balancing this equation. Okay, so the next question is, we have this question E, and in this question complete table 1.2. Okay, by placing a tick to show which of the compounds have molecules with an overall dipole moment. Okay, so if you see this example number 1, carbon dioxide, you can see like in carbon dioxide, C double bond O, you can see oxygen is electronegative, this oxygen is electronegative too, and carbon is electropositive. So what is dipole moment? It is actually product of charge and distance between them. Okay, so dipole moment is, you know, it is a vector quantity. It is a vector quantity. Okay, and its direction is from like positive end to the negative end, positive end to negative end, and see, you can see it as well from positive to negative. So now you can see actually they both are like polar bonds, but overall dipole is 0 because they are cancelling the effect of each other. So you can see it is not a like polar one. Okay, if you see the next example, here we have sulfur. You know, carbon doesn't have any lone pair of electron, but sulfur have this lone pair of electron, and it is making the bond with this oxygen and making the bond with this oxygen. Okay, if you notice this lone pair of electron, according to Vesper, it will repel these two bonds. Okay, it will repel these two bonds, and you know it is negative, more electronegative than sulfur, so the direction will be from positive to negative. So direction will be from positive to negative. Okay, so it can bear some, you can say, dipole moment. Okay, so what about this sulfur, carbon and sulfur? If you see on the right side, I have this carbon connected with this sulfur and with this sulfur. It is similar example just like carbon dioxide. You can see instead of oxygen here we have sulfur, but it is electronegative. It is also electronegative and carbon is electropositive. And still you can see like they have dipole moment from positive to negative. Okay, so from positive to negative you can see they cancel out the effect of each other. Positive to negative as well as positive to negative is the direction of your dipole moment, so now they are cancelling, so it means it is not a dipole moment. Okay, it's not showing in dipole. Okay, so what about this? We have sulfur, then we have this carbon, and then we have this oxygen. So you can see oxygen is more electronegative. It is more electronegative, it is pulling the electron of this carbon, it has become a polar. You can see it is a more polar region. Okay, from positive to negative due to inductive effect. What is inductive effect? For example, if oxygen pulling the electron of this carbon towards itself, so It means like sulfur is also its electrons are slightly being attracted towards this side. Okay, it is slightly positive as well. So now you can see this area is polar, so you can see it also bears some dipole moment. Okay, so the next question is, at 150 degree and 130 kilopascal, all of the compound listed in table 1.2 are gases. Okay, use this condition. 0.284 gram of one of the compound occupy a volume of 127 cm cube. Use this information to calculate the MR of the compound, hence identify the compound from those given in table. Okay, so show your working as well. Okay, so you know when conditions are not given at room temperature and pressure, if conditions are given in room temperature and pressure, then we will use like 24 formula. Okay, 24 decimeter cube molar volume formula. But now conditions are not at room temperature. You know, pressure is not according to room temperature and pressure. Okay, so here you can see your pressure is given in kilopascal, temperature is given in degrees Celsius. Okay, so now we will use that equation, famous equation, PV is equal to nRT. Understand? So we need to find the MR. For finding this MR, you know, we will rearrange this equation. And how can we rearrange this? You can see like PV is equal to, you know, it's number of moles, and number of moles is equal to mass divided by MR. Okay, molar mass. Okay, RT. If I rearrange this equation, you know, it will become MR will be equal to MR equal to mass, okay, or general gas constant temperature divided by pressure multiplied by volume. Okay, so what is important in this question? The question important thing is like temperature is given in Celsius. You need to convert this temperature into Kelvin. Okay, we need to convert this into Kelvin, and here you can see 103 is in a kilopascal, but we need this thing into Pascal. Okay, and other thing, volume is given in centimeter cube. You need to convert centimeter cube into meter cube. Okay, so first step is, for example, if I write it here like pressure is given in Pascal, so I need to convert the pressure into Pascal. Okay, so you can see question given is 103 kilopascal. If I multiply this 103 with 1000, I will get the answer into Pascal. Okay, I will get this answer into Pascal. Okay, so other thing is volume is given and I need to convert the volume into meter cube. I need to convert the volume into meter cube. Okay, so you know 1 centimeter cube, 1 centimeter cube. Okay, it is equal to 10 to power minus 6 meter cube. Okay, so now how can I solve it? I need to convert this volume, so it will become 127 into 10 to power minus 6 meter cube. Okay, other thing is I have this temperature 150, so I need to convert this 150 by adding 273. Is it clear? So when I will like combine together, I will get 393 Kelvin. I hope you got this conversion. Okay, so now by using this formula, what is our formula? It is, you know, MR is equal to mass multiplied by R is 8.31 multiplied by given temperature in Kelvin over pressure in Pascal, volume in meter cube. Okay, so let me put this value. So given mass is given 0.284. You can see it is 0.284. Okay, multiply by R values, you can see at the end it is 8.31, always a constant value. Okay, so multiply, so you need your this temperature, and temperature is 393 Kelvin, 393 Kelvin divided by, so you can use this pressure 103 into 10 to power 3 multiply with 127 multiply 10 to power minus 6. Is it clear? So when you use your formula, use your answer. Okay. So hurry up. You should find out its answer. Okay. And it should be equal to 76.3. Okay. 76.3. What's the answer? You can write it here. You can see it is 76.3. Understand? Identity of compound. Now we need to find out the MR of this compound. We need to find out the MR 76.3. You know, oxygen's MR is, if we see the like MR of this oxygen, it is 16. But here we have two oxygens, 16 multiplied by 2. Carbon's MR is 12. Understand? So if you will add them together, you know you will get 44 gram. Okay, so it's not a compound. Okay, so you know oxygen MR is 16 multiplied by 2. Sulfur MR is 32. Okay, so it is equal to, you know, you will get this 64.1. Okay, 64.1. 64.1. So what about this? You can see sulfur is 32 and this sulfur is 32 plus 12. Okay, so you can say 32 for this 32 and plus 12 plus 32. Okay, 3 3 60, then 10 70, then it will get, you will get this 76. Okay, 0.2. It means if you compare, this is 76.3 and it is 76.2 almost. Okay, so it means your compound is CS2. Okay, you can see it is CS2. It is your answer. Okay, so now, so next question you can see from here. If I proceed next on this page, so the question is, you can see the group 2 elements magnesium to barium all are silvery white reactive metals. Draw a label diagram to show the bonding and structure of the group 2 metals at room temperature. You know, if we draw the structure metal like electron C pool, you can see like in metals they have cations in the center and they are surrounded by their free electrons. Okay, cations in the center and they are surrounded by their free moving electrons. Even you can say they are delocalized electrons. Okay, so because they are from group 2, you need to, because they have two positive charge. Group 2 carry two positive charge, and you know 2 positive mean they are surrounded by 2 electrons. So you can also draw like this with 2 electrons. Okay, they are known as free moving electrons, free electrons, delocalized electrons, mobile electrons. Okay, is it clear? So I'm displaying, showing you, because the central part is 2 positive because it is a group 2 metal. So there are 2 electrons. Is it? Explain why magnesium has a higher electrical conductivity than sodium. So you can see sodium is from group 1. Sodium is from group 1. Okay. So now you can see if something is from group 1, it carry positive 1 charge. Magnesium is from group 2. It is carrying 2 positive with 2 outermost electrons. Okay. So it means magnesium has more electrons. Magnesium atom has, magnesium atom carry, even you can say, okay, more electrons than sodium atom. Okay, then sodium atom, because sodium is from group 1, so each atom will carry only 1 charge, 1 electron. Magnesium is from group 2, it will carry 2 electrons. Okay, per atom. Okay, write an equation to for the reaction magnesium with cold water. You know, group 2 metals, when group 2 metals react with cold water, you know, we get hydroxides. Okay, for example, if you have magnesium group 2 react with water, you will get magnesium hydroxide. Okay, because you know magnesium is from group 2, hydroxide carry negative 1 charge, so I need to put here 2, and you know it is a highly exothermic reaction with hydrogen gas. It also gives hydrogen gas. So now I need to balance this equation. So if there's 2 hydroxide 2 times, so I need to write here 2. Is it? So you can see rest of the equation is balanced. Okay. Identify a single reagent that can be used to distinguish separate sample of dilute magnesium nitrate and dilute barium nitrate. So if you check this, it's an important question. So you people need to know, like the reagent for these two ways, sodium sulfate. It is sodium sulfate. But the question is how? For example, reason number one, if you react sodium sulfate with the magnesium nitrate, okay? So for example, if you have this magnesium nitrate, if you have magnesium nitrate and it is reacting with sodium sulfate, you can see you will get like magnesium with the sulfate, you will get magnesium sulfate, plus you will get sodium nitrate, you will get this sodium nitrate, okay, NaNO3, okay. So here 2 sodium, so need to multiply by 2. So you can see it is soluble salt. It is also water soluble salt, okay. Magnesium sulfate, sodium nitrate, they both are water soluble salt, okay. If I draw chemical equation for other case, for example, if I react with the barium nitrate, okay, suppose if I have barium nitrate 2 times and react with sodium sulfate, so then we will get this barium react with sulfate, so barium sulfate, and we will get sodium nitrate, okay. So the thing is, barium sulfate is a solid. It is like precipitate, white crystal solid, okay, white crystalline solid, okay. It is a white precipitate, okay, white PPT. So now you can see when you use Na2SO4, okay, so magnesium and sulfate and barium sulfate, okay. So magnesium sulfate will easily dissolve. You can see MgSO4 soluble in water, while you can see in this equation barium sulfate is insoluble. It will give a white crystalline precipitate, okay. You can see, even write it will produce a white precipitate. It is a famous test for sulfates, okay. Even you, I hope you did this in your O levels, okay. Test for sulfates, then we use this barium sulfate, okay. So here we have next, you can see this page, I hope. Describe the observation when SRI2 strontium iodide reacts with concentrated, okay. Sulfuric acid is a strong oxidizing agent. Sulfuric acid is strong oxidizing agent, okay. When strontium iodide, it will react with A2SO4, okay. You will get, it's a very famous reaction, and you should know sulfuric acid is a strong oxidizing agent, okay. So you will get hydrogen iodide with strontium sulfate, okay. We will get strontium sulfate with hydrogen iodide. We will get this hydrogen iodide, plus we will get this with strontium sulfate, okay. But in actual, this reaction is not a simple one, okay. It like continues the reaction, because why? Because sulfuric acid is a strong oxidizing agent, it further oxidizes this hydrogen iodide. But we have, because 2 marks question, so we have to like limit in the answer, okay. So sulfuric acid further oxidizes this hydrogen iodide. So this hydrogen iodide further oxidized with sulfuric acid. Is it clear? And now you will get this iodine. The actual reaction of this reaction is production of iodine, okay. You will get SO2 gas, plus you will get 2 moles of water. Here you can see you are getting iodine. So what's the color of iodine? So you can write it here, observe. So you need to write in the observation. So observation something like, for example, you can see in the chemical reaction. So when it means you're reacting them, so purple color of iodine will form. Okay, so you can notice it purple color. Okay, purple color of iodine will form. Okay, it is your observation. Compound XL anhydrous group 2 bromide dissolved in water and titrated against aqueous silver nitrate AgNO3 is given. Okay, so next, a solution containing 0.250 gram given mass of X requires 33.65 cm of 0 point. You can see it's the volume, it is the given volume, and it is the concentration. Okay, mole per dm cube, it is a given concentration. For complete reaction, identify X, show your working. Okay, so now if you notice this, like we have group 2 bromide. Group 2 means you can see we have something unknown. For example, you have this X bromide Br2. It is reacting with silver nitrate. Okay, and now you are getting actually silver bromide. Okay, you will get this silver bromide plus you will get this X amount of nitrate. So if I balance this equation, you can see here I have Br2. I need to multiply with 2 this side with Br with 2. Okay, because for balancing this equation. Okay, if I multiply with 2 Ag like silver bromide, here 2 silver, so it also need to multiply this side with 2. Okay, for balancing equation. So now you can see 2 is also multiplied with this nitrate, but here is the nitrate, so I am like writing this nitrate into 2. So now equation is balanced. Okay, so now step one is find the number of moles of silver nitrate. Okay, so what's the formula for moles? You know, moles is equal to given mass over mr, molar mass. Okay, so what is the given mass of this? So you can easily use it. My bad. How? Because we will use this moles is equal to volume multiply concentration. Okay, because volume is given and concentration is given. You can see, you know, volume is given in centimeter cube. I need to convert the centimeter cube into decimeter cube. It is 33.6 divided by 1000 multiply by what is the concentration. You can see it is 0.0500, 0.0500. Okay, so what are the moles for this? You can get is 0.00, 0.00168425, 168425 moles. We got the moles of silver. Now step 2, find the moles of this. You can see they are 2 moles and they are 1 mole. So step 2 is find the stoichiometric ratios. Okay, stoichiometric ratios. You can see this 1:2. Okay, so if 2HNO3 is 0, here you can see 0.00168425. So we need find the moles of this X. You know it will cross multiply with each other. So it will become, X will become equal to 0.00168425 divided by 2. Okay, so now you will get the moles of this. So let me write it here. 0.000, 0.000. Okay, 842125, 842125. So now we got the moles of this. Is it clear? So now step number 3, we need to find mr. Step number 3, we need mr. Okay, so what is the formula for mr? You can say mr is equal to mass over moles. Mr is equal to mass over moles. So what is the given mass? It is 0.250. It is 0.250. 250. So number of moles are given 0.0008422125. Okay, so now I will get their number of moles. Okay, so it is 0.0008422125. So I will get the math. Let me find it. 0.250 divided by 0.0008422125. So here's the answer. So MR is equal to, actually you can say, 296.5 296.5 gram per mole. Okay, is it clear? So it is already done. So now we need to find group 2 member, any member of group 2 which must possess this MR. Okay, understand? So if you notice on this Br2, like MR of Br is, if you see, MR of Br is 1 Br is 79. Let me check from here. It is given 79.9. Okay, it is 79.9. Because we have Br2, it will multiply with 2. Okay, so other thing is, if I check the periodic table, so MR of beryllium Ba, okay, it is 137.33. 137.33. Okay, so if I like add them together, so we will get this Ba. Okay, Br2. Answer will become Br2. Okay, Br2. Okay, understand? So if you like add them together, you will get this answer. Okay, really sorry, space issue. Okay, so now next question is, you can see from here, is from organic. Okay, alkene undergo addition reaction with the 1,1 mixture of CO and H2 to form aldehyde. Okay, so now you can see we have this alkene here, and here we have carbon number 1, here we have carbon number 2, carbon number 3, and it is carbon number 4. Okay, define addition reaction. You know, addition reaction means you're breaking this double bond and you're converting into the product. Right? So addition reaction is addition of substance with the expense of a breaking of double bond. Okay, so your addition of substance, addition of a substance by breaking a double bond. Okay, a double bond. Okay, because you can even say like such reaction which is making single product. Okay, aldehyde A and B are structural isomers. Yes, I can see it here. You can see if it is carbon number 1, it is carbon number 2. It is making a chain. For example, you can see it here. It is CH3. It is CN. Now you can see your function group is here, double bond. It is an aldehyde function group. Okay, it is here. So now it is connected with this hydrogen, and this is CH3. Okay, so now this your function group carbon will become carbon number 1, it will become carbon number 2, and it will become carbon number 3. Is it clear? So you can say 2-methyl propanol. Okay, so it is 1-methyl propanol, 1-methyl propanol, it is 2-methyl propanol. Okay, so what's the next thing? State the type of structure isomerism shown by A. It seems, looks like just like a position isomer. Student get confused, like function group is on carbon number 1, but in B function group is in carbon number 2. But actually, you know, it is an aldehyde function group. In your organic chemistry, two function groups, number 1 aldehyde and number 2 carboxylic acids. They always, either they present extremely right or left. Okay, and their carbon will be always a carbon number 1. Okay, so it is the reason this is a structure isomerism, not a position isomerism. Okay, answer is structural isomerism. Okay, And structure you can say is a type of chain isomerism. Okay, if you like further classify it, is a type of chain isomerism because one of the chain is long and other is in branch form. Okay, is like chain isomerism. Chain isomerism. Okay, so name A. You can see carbon number 1, 2, 3, 4. It's a butamine, 4 carbons, and when there is Al at the end, it means some aldehyde. So it's a butanol. Okay. So now we have next question. The complete reaction of propene with the 1,1 mixture of CO and A to produce A and B. The product mixture contains 96% A and 4% B. Calculate the mass of A produced in this reaction when 5.00 into 10 to the power 3 kg of propene is used. So first we need to write the equation. So you can see, you already told you like, you have like C3H6, propene, C3H6, okay, and it is 1:1 ratio you can say, reacting with carbon monoxide and also reacting with hydrogen. And what is our product? You can see C4H8 oxygen, C4H8O. He is talking about that A, okay, above structure formula, okay. So now let me like make it clear for you here. You can see it, okay. If you see the structure, you can see one hydrogen, two hydrogen, three hydrogen, 4, 5, 6, 7 and 8 hydrogens. Okay, how many carbons are there? 1, 2, 3, 4 carbons, 8 hydrogen with oxygen. Okay, C4H8. Okay, I hope you got this point. Okay, now, so the question given here you can see like it is in kilogram. So now I need to convert this into gram. So if I like multiply with this, 1000, so I will get this, for example, mass of this. I need to find the moles of this. Moles of like C6, C3H6, okay? It is C3H6, my bad, it's not this. It is C3H6, okay? Moles of C3H6. What is the formula of moles? Mass over MR. So what is the mass? It is in kilogram. So how can I convert into, you can see 5.00 into 10 to the power 6. I convert into gram divided by MR of the C3H6, okay? Carbon is 12 multiplied by 3 plus 6, okay? 1 carbon is equal to 12 MR. 3 carbons are there, 3 multiplied by 3. 1 hydrogen is 1, so I multiply with the 6, okay? So now what will be the answer? It will become 42. 42. So mass over MR. So what will be the moles? Let me find 1 second. It is 5 into 10 to the power 6 divided by 42. So answer is, you can see 119047.6 moles. Is it some moles of this? Understand now? So now the question is, because we need their mass, okay? So we need to convert their mass. But the problem is, it is producing 96% of A. So first we need to find their 96%. 96% of what? 119047.6. Understand? So it will become, like if I got this, so the answer will become 114285.696. It is actually 94%, okay? It is actually 94% of this, okay? So now how to find its mass? I need to multiply with its MR. So how can I got its MR? You can say it is like C4H8 and oxygen, okay? C4H10 oxygen. Let me find MR. Carbon's MR is 12. There are 4 carbons, multiply with 4. 8 hydrogen, so it is 8 plus oxygen is 16. So it is 12 multiplied by 4, 48 plus 8 becomes 72. MR is 72. Is it clear? So you know how to get the mass. So mass is equal to, formula is mass is equal to moles multiply with MR. So you can see these are the like 96%. You can see the 96% of these moles multiply. What is the MR? You can see MR is 72. So now what is the like mass? You can see it is 8222. Even you can round off it. Okay, 8230. So mass of A is actually 8230 gram. Okay. I hope I'm solving simplified method for everyone. Like every student can easily understand this question. I'm hopeful. Okay. So what's the next page? Is it cost page number? I think now start from this. Okay. We have done this. Now the next page is this. Sorry. Here's the question. A and B show reactions typical of aliphatic aldehydes. Aliphatic means straight chains, okay? They are mostly straight chains, okay? Like aliphatic mean in chemistry oily, oil formings, okay? But we mostly use for in A level, we told you people like when straight chain or even if they are in cyclic form, but they're different from the benzene compound. You know, benzene are in A2, you will discuss about benzene, aromatic hydrocarbons, okay? So A undergoes the nucleophilic addition reaction with a mixture of HCl and KCl forming compound C. Complete the diagram to show the mechanism for this reaction. Include charge, dipole. Okay. So now you know, like cyanide group is a act as a nucleophile group. Okay. So you can see it here. You have this CN. It is also known as a nitrile group. C triple bond N. Is it clear? It is known as a nitrile group. So you can see you like carbon can make maximum 4 bonds. Okay. So you can see it will act as a, and good thing is it can act as a nucleophile as well as electrophile. Okay. So we will discuss later how. So you can see you have this cyanide CN group. It is acting as a nucleophile. And here you have this electrophilic carbon because carbon is attract with electronegative oxygen. So now you can see like this negative will attract over this carbon and the one of the bond of this it will broken down. Okay. So when you will broke down this, so it you will get this H is the carbon with this oxygen negative charge. Okay. And what about this CN will attach over here. CN is here. And this side is C3H7. C3H7. Understand? So, you know, you have mixture of HCN and KCN. Okay. So now what will happen actually, you can see like this hydrogen with triple bond with CN, like another nucleophile will generate. Okay. So it will attack over this electropositive carbon and you will get this OH. Is it clear? So now you are regenerating this cyanide as a nucleophile. Okay. It is actually a base catalyzed reaction. It is not given in your A-level syllabus, but I am telling you because when oxygen is, you can see when this oxygen is attacking over this hydrogen, you can see a nucleophile is generated. So the question is how this first nucleophile generated. Okay, of course we use some base and this base actually start this reaction. Okay, for generating a strong nucleophile. Okay, anyhow we are done this. Okay, the next question is experiment 1 reagents turns solution turn from orange to green. You know primary alcohol oxidize, secondary alcohol oxidize, but tertiary alcohol doesn't oxidize. Okay, this question from oxidation of alcohols. And you know What is the reagent for that solution? It is acidified. As positive mean it is acidified potassium dichromate K2Cr2O7. Okay, it changes color from orange to green when primary or secondary alcohol oxidize with this. Okay, a silver mirror forms on the sides of, okay, you know, it is a test for distinguishing between aldehyde and ketone. So it is a tolerance test, tolerance reagent. What is the tolerance reagent? Ammonical silver nitrate. You can simply write it even tolerance reagent. Okay, but if you are good with the chemistry, so what is the tolerant reagent actually? It is ammonical silver nitrate. It is ammonical silver nitrate. Okay, you know, silver acts as an oxidizing agent and convert into pure silver. Okay, so now what's the bromine? So you can see there's no reaction for bromine for this the observation involving B. So bromine react with double bond, and you can see here there's no any double bond. Okay, you can see there's no any double bond even with the B. Okay, I should go back. There's no any double bond. Okay, so when there's no any double bond, it means there's no reaction. There is no reaction. C4H8O is oxidized by acidified potassium manganate. Complete the equation for this reaction. Use oxygen to represent, you know, oxidizing agent mean potassium dichromate. It provides oxygen for oxidation. Okay. So C4H8 is already given. Is it clear? So now you can see it is providing oxygen. When it's providing oxygen, you will write this atomic oxygen. When you write something in this bracket, in chemistry it is known as nascent oxygen. Even you can say it is the atomic form oxygen. It is more reactive than molecular form. Okay, when you write this O2, it's a molecular form, but when you have this atomic oxygen, it is more reactive. Okay, so then you will get this C4H8O2. Okay, so now I think I should go proceed to the next page. Here we have this next page. Okay, so what's the question? C is a chiral molecule. What's a chiral molecule? When a carbon connected with four different groups. Okay, when a carbon is connected with four different groups, that carbon is known as a chiral molecule. For example, if you see this carbon, it's connected with group 1 OH, connected with hydrogen 2, connected with nitrile group. Okay, 3, and the whole thing is this whole is a different group. Okay, so when a carbon is connected with four different things, this carbon is known as a chiral carbon. Okay, I hope you people understand this. So just let me draw that steric on this carbon to tell you this carbon is a chiral carbon. Okay, so when propene reacts with carbon monoxide and an excess of hydrogen, alkane and a mixture of alcohols are formed instead. The alcohols are isomers of each other. So just a molecular formula of the alkane and the alcohols that are formed under these conditions. You know, when we use it, like what type of alcohol and what type of we can have it. Okay, so you know it will become like alkane. We can get the C3H8, C3H8. Okay, and next molecular formula of alcohol. So we can get this from here. You can say C4H10O. But how? You know, when propene reacts with CO and excess of A2, you know, propene is, we already done this like C3H8. Okay, yes, and this, so reacts with CO and excess alkane and mixture of alcohols. Okay, so it is the molecular formula for alkane and it is the molecular formula of this. Okay, so important points is alcohols are isomers of each other. Is it clear? So now we'll get this C3H8 and C4H10 oxygen. Okay, the next question is the reaction of ethene with 1,1 mixture of Cu and A2 is shown in equation 1. Equation 1 is given. And at atmospheric pressure, a cobalt-based catalyst is used in this reaction. State and explain the effect of using a catalyst on this reaction. The first thing is, catalyst doesn't affect this equilibrium. Catalyst doesn't affect this equilibrium. It just speeds up the chemical reaction. It just speeds up chemical reaction by lowering activation energy. By lowering activation energy and providing new path to the chemical reaction. To the chemical reaction, okay? To the chemical reaction, okay? So now we can proceed to the next topic. Here it is. Why the yield of CH3, CO2, CH2 increase when the overall pressure of the reaction mixture increase? You can see this is from equilibrium. So when you increase the pressure, when we increase the pressure, okay? So let me count the number of moles. You can see product side number of moles are 1, and on the left side number of moles are 3. 1 mole of this plus 1 mole of carbon monoxide plus 1 mole of hydrogen. So you can see on the left side number of moles are 3. When you increase pressure, and if reactant products are gases, so equilibrium shift to the right hand side which contain less number of moles, okay? So equilibrium will shift to the side which contain least number of moles. Why the yield of this increase when the overall pressure of the, because you can see product side product side product side has less number of moles, okay? Less number of moles. Is it clear? So the next question is, okay, now we need to find enthalpy change, delta Hr of the reaction in equation 1. So how can we figure out, okay? It's also easy, not a difficult. So when you find like formation, so how to write it? We need to write reactants here. We will write here reactants. We will write here products. And we will write here their elements form, okay? Their elements, okay? So what are your reactor? You can say C2H4. Let me change color. We have this C2H4 plus CO plus H2, and we are getting this CH3, CH2, CHO. So what are the elements? You can see two carbons are here, like carbon exists in the solid form in the nature, so it is a carbon, but here C2, so I need to write here two carbons, and it exists in the solid form in the nature. Never forget to mention this physical states, okay? So now you can see you have hydrogen H4. So hydrogen exists in nature in H2 form and in gaseous form, but it's H4, so it will become 2H2, okay? So what about other? You have this carbon monoxide. It is still a carbon, and plus oxygen is there, so it will become 1 over 2 O2, because oxygen exists in nature in O2 form, okay? It's important to write in such a way, okay? So when these elements combine together, so when these elements are joined together, you are getting these reactants. These reactants combine together, you are getting these products. So when these elements even combine together, they are also producing these things. Is it clear? If you notice, this chemical reaction, it is moving from this element to reactant and then product. to this form. Okay, elements, then reactants, then it is moving this product form. Okay, so how can I help you to solve such questions? I know students they become little bit confused, but it's not a difficult one. Believe me, it's a simple one. So arrow direction is from left to right. So let me explain you how to write this. Let me use some razor first. We remove everything for you. Okay. Yes. So now how I will solve this. So my point is you can see C2H4, C2H4 plus CO plus H2. Here you can see over here we have delta H of the reaction, delta H R of the reaction. Okay. Here we have product CH3, CH2, CHO. Understand? So how to solve it? Be with me. Okay. So add this thing, combine these things. Okay. Reactant with this delta HR, combine these things, everything. Okay. So I'm writing it C2H4 plus CO plus H2 plus delta HR equals to, now you write to this product side, equals to CH3, CH2, CHO. I hope you got this point. Okay. Now put their values. So what's the value of C2H4? You can see it's positive 52. It is positive 52 plus what's the value for this CO? Minus 111. I'll put bracket here, minus 111. Okay. So because hydrogen is in element form, when something is in element form, it's like delta H formation will be 0. Okay, delta H formation will be equal to 0. So there's no like formation is given here. It is. So plus, I told you, plus this delta HR equals to CH3, CH2, CHO. So what's the like CH3? It is given minus 187. Okay. So delta H, so first you can like solve this thing. Okay, like minus, you can say minus 111 plus 52. Okay, so if you solve this, so you can get your one answer. It will become minus 59 plus delta HR equal to minus 187. Is it clear? So now you can see how to find this delta HR. You can see it is minus 59. When it will move, it will become positive 59. So delta HR, it will become minus 187, and this minus 159 will become positive 59. Okay, and your delta HR will be equal to, you can check, minus 128. So you're, how simple it is. Okay, people like make you confused, I know that. Okay, so simply just reactant side, when the reaction is left, making that clockwise anti, okay, clockwise direction, just add them together like this, C2H4 CO then H2 plus this delta HR equal to your product. Okay, what their values, you can simply figure out the answer. Okay, so the next question is, the reaction mixture code to collect CH3 CH2 CH as a liquid, identify all type of van der Waals forces that are present between molecules of, you can see, if you check the structure of this, you have this CH3, CH2, and then C double bond O, and here you can see H. Okay, so you notice a positive charge and it is a negative charge, and because of this polarity you can see, number one, there are permanent dipole, there is permanent dipole force, you can see. Is it clear? Number two, you can see this region organic area. Is it clear? So because of this organic area, you can see it can induce for a sometime temporary as well. Okay, so there is as well temporary. Why temporary? Because when this molecule will come close to other molecule, this oxygen area, similar molecule. Okay, so for example, it is CH3, CH2 carbon double bond oxygen with this hydrogen positive. It can also induce temporary forces, okay, temporary dipole, okay, between this hydrogen and, okay. So the next thing is, I hope you're getting how to solve the paper, okay, how to understand the paper, okay. So I think, yeah, this one, okay. It is really hard to solve all the paper. Okay, there's some questions and you can see. So you have this bromine. You can see this bromine double bond. It means one of the hydrogen from here and bromine HBr. Okay. So they are removing from there. You are getting double bond here. Okay. And this double bond further is making addition polymer. Okay. So now you have Br. Here we have this hydroxide. Okay. By adding the reaction with ethanol, then AgNO3. Okay. Understand? So the next question is reaction 3 iodoform test and reaction 4 KCN, okay, nucleophilic substitution reaction because CN replaced with, then it's the reduction because lithium aluminum is strong reducing agent. So let's move to the question. State the reagent condition used to form E in reaction 1. Is reaction 1 order to its elimination reaction. What are elimination reactions? Removal of atoms from adjacent carbons. Removal of atom or molecules from adjacent carbons, and they both are removing from here. So what are the conditions? So just he is just asking about their conditions. Okay, so for elimination reaction from the chapter is halogen alkane. Elimination reactions conditions are given, like we use some base KOH or NOH. You can write here sodium hydroxide, or you can write potassium in alcoholic condition in alcohol. Okay, with other condition you can see heat under reflex. Okay, heat under reflux. Okay, so the next question is, draw the structure of one repeat unit of the addition polymer of that forms E. It is an E. It is CH3. You can see it here, CH3. This carbon is making double bond with this carbon, and further it is CH3. Okay, and 1 to 3 here we have this hydrogen, and here we have this hydrogen. Okay, so he is asking to write its, when writing the structure of polymer, we need to remove this double bond. Okay, it will become carbon to carbon with this CH3, with this CH3, with this hydrogen and this hydrogen. It is the formula. Okay, now I will write that here. It will become carbon to carbon with above methyl group is here, other methyl group is here. Okay, so hydrogen, and here is hydrogen. So now it is further available for connectivity. Okay, E also formed from F is heat strong in the presence of aluminum. It is a dehydrating agent. It is a dehydrating. Okay, remove water. Okay, so E also from F is heated. Where's the F? Okay, now if you heat this F, you can see it is the F, and it is hydrogen from here. This hydrogen and this OH, they will combine together, and now you will get this E. Okay, you will get this E. You can draw this E here as well. You will develop double bond here. Okay, so it's another type of elimination, like dehydration. Water is eliminating from here. So how? You can see OH from here and one of the hydrogen will here. So what is elimination? A reaction in which OH removed from this alpha carbon and hydrogen removed from this beta carbon. So your function group is actually connected with this carbon. That is why this carbon is alpha, and this carbon is directly connected with your alpha. It's a beta carbon. It's another beta carbon as well. Okay, because double bond is here, so that is why removal is from here. Okay, so don't be confused with this. Okay, so elimination reaction. Okay, so condition is, write an equation for this reaction. So already told you, like it will become C4H10O, C4 H10 oxygen, and now because you're removing and it's becoming C4H8, C4H8 with water, okay, because one molecule of water is being released. You can even see it here. How is it possible? So it is 1, 2, 3, 4. So you can see it is carbon number 1, 2, 3, and 4. You can see double bond is here, OH, and one hydrogen from here. What I told you, they are removing, and you will get the double bond here. Is it? You will get double bond here. Okay. So one carbon, 2, 3, 4 hydrogens. 3 hydrogens are there. 3 hydrogen, 1 hydrogen is here. 1 is here. 4, 5, and 3 here. 8. And this OH and H, it will become your water. Okay. So now the next question is, so here is the next question. You can see. So bromine is once again, I think, is the very same. Okay, from this. Predict what is observed in reaction 2. Where is the reaction number 2? Bromine with silver nitrate, ethanol in 2. So you can see the silver nitrate. Is it asking about this question? Is a part of this? Yeah, B, predict what is observed in reaction 2. Okay. So you have silver with bromine. Okay, I got my point. You know, silver iodide, it gives white precipitate. Okay. Silver bromide, it gives cream precipitate. Silver chloride gives, my bad. It gives white. I forget that. It gives white. It gives yellow precipitate, and it is producing cream precipitate because bromide is here. You can see it's a bromide, and you're reacting with the silver nitrate. Is it clear? So you will get another thing. It is a cream precipitate. Okay, so we will get that cream precipitate here. Cream precipitate. Okay. Identify the yellow precipitate and the organic ion form in reaction 3. Okay, reaction number 3. So then I should go back. So you can see it is an alkaline aqueous. Okay, so it's a iodoform test. This question is from iodoform test. So you know triiodomethane. Triiodomethane is responsible for this yellow precipitate. Triiodomethane is for this, and because you have this, you will get this negative ion here. Even you can get this other product, oxygen with sodium. Why? Because you are using here alkaline. Alkaline in, you can see from your book, we use in the presence of sodium hydroxide. So you, because he is right asking about this ion, okay. So I can write it here. A yellow precipitate organic compound with this, okay. So go to the next page. So you can write it here. Iodoform test triiodomethane. It's a triiodomethane. Okay, so next we can get this CH3CH2. Is it clear? Then CO2 negative ion. Even CO, I think you should make sure about this. Okay. So the type of reaction that occurs in reaction 4. So where's the reaction 4? The reaction 4 is here. You can see. Let me raise this. Really sorry if you people are hearing the background noise. Okay, here you can see is a Cn negative. When this Cn negative, it will attack over this electrophilic carbon. Bromine will remove from here. Okay, so you will get this Cn. It is nucleophilic substitution reaction. Type of reaction is, it is actually nucleophilic substitution reaction. Okay, nucleophilic substitution. Okay. Okay, so now reaction 5 is similar to reaction lithium aluminum hydride with carbolic acid to form alcohols. Suggest the role. You know, it's a strong oxidizing agent. It is already known. Okay, is a reducing agent. Lithium aluminum hydride is a reducing agent. Okay. So the next is, okay, graph is given. You can see IR infrared. Use the information from table 4.1 on page 14 to identify like which of the compound DEFGH produces the infrared spectrum. Okay. So now we should go to like, now I should move to parallel. I should go here as well. First I will check the value from here. Understand? So now you can see it here. We have this value. Okay. Go back and find it from question. What's the question? Identify which of the compound DEFGH produces the infrared spectrum in figure 4.2. Okay. If you see it here, you can have these values. For example, let me check what is happening on this 3000. Okay, what is happening here in 3000, what type of value is there? So the 3000 is around, you can see it here, 333 to it is amine and amide it is making, or you can see amine or amide value, this one, but I think there's no any amide value, but yeah, there's no any amide group. Okay, so then I need to go back and check some other value. For example, what is happening in this 1500, if I like see here. Okay, and between this region, the broad area. Okay, between 1500 to 2000 value. Okay, so if I go there, let me check from here. So here we can see 1500 to 1680 aromatic compound like alkene. Yes, it is possible for alkene because we have that alkene there. Okay, is it clear? So other thing is there any other possibility for this? Can we see it? If I check this area between 15 to 2000, 15 to 2000. Okay, so 15 to 16 we have aromatic compound alkene, and if you check this nitrile group is between 2200 to 2050 nitrile group. Okay, so it is 22 between this, it means there's some nitrile group, C triple bond, and is this region. Okay, yes. So which compound does have this? Here we have the G. So you can see G have nitrile. So it means nitrile is there. Okay. Is there. So you can see it is being absorbed around this 2200, 22,000 to 2200. Okay. So absorption peak is at peak is around 2200. Unit is EM negative or wave number. Okay. So the next question is, okay, congratulations, your test is over, finished, khalas. Okay, so it was all from my side. If you people have any question, you can ask me in comments. My certain videos are in Urdu and certain are in English, but now I'm preferring to make videos in English. Allah Hafiz everyone, goodbye.